Okay, right. We have a picture on the display. It's all a bit jittery, as you can see. Let me just get you guys a nice picture of that. So that needs to be over on the left. Which it is. Okay, so that's on the GND position. Check voltages at the points as shown in the photo. Okay then. So let's turn that over, and we need to check that we have certain voltages in certain places. Okay, right, so check the following voltages. So, oh come on, there's loads of this. Boring. I'm really tempted just to use it and see what happens. Okay, right. V plus should be 8.35. Let's check our input. So let's start ground, input. 9 volts at input. Okay, V plus should be 8.35. V plus. .3, good enough. Okay, AV plus should be 5 volts. AV plus is somewhere in the middle, there it is. AV plus is indeed 5 volts. V minus should be minus 7.86. V minus, minus 7.6. Stuck in the probe. Let me see. AV minus should be minus 5. Minus 5. V1 should be 0. Well, V1, 2, and 3 should all be 0. V1. Millivolts. V2. Millivolts. V3. V3 is somewhere in the... There it is, V3. Nothing. Cool. Just notice we've got a diode on the back there as well. Blah, 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 blah. V4 should be minus 1.65. V5. Oh, the diode's doing stuff while I'm probing that. 1.65. Okay. Nice. So our voltages are all correct. Step 5, calibration. Connect the red clip to the test signal terminal and leave the black clip unconnected. See photo at the bottom. The analog board is not very well connected. There we go. Right, so red test probe to the test point. I assume, see that says 1 kilohertz, so I assume that's generating a 1 kilohertz test signal. Okay. Apply power and boot, we already have. Okay, then hold adjust dial for 3 seconds to bring up test signal amplitude display at lower left corner. Okay, so 1, 2, 3. Okay, test signal amplitude. That's as good as I can get. Okay, that'll do. Right. Push adjust to set amplitude to 0.1 volts. There we go, 0.1 volts. Set sensitivity to 50 millivolts and adjust trigger level so waveform stable. Okay, so set sensitivity to 50 millivolts. Okay, that's seconds. V divide, okay, to 50 millivolts. Nope, how about that one? Ah, there we go. 50 millivolts. There we go. Haha. We're winning. And adjust trigger level so waveform stable. Okay, well on norm, that looks pretty stable to me. Okay. Tuning C3 so that sharp rectangle, photo B at left, is obtained. Then adjustment for C3 is done. Okay. Right. C3 is a switch. Oh, you might be right. Oh, yeah. You're right. C3 is the switches on the back. I know where those are. You're absolutely right. Okay. Oh man, that's going to be a ball ache to get to because it's on the other side of the sodding board. Okay, that's on the analog board. Now the problem is I think I'm supposed to be seeing this square waveform at the moment and I'm not seeing it. However, I noticed that they're set to DC on this picture. Nope. 50 millivolts, okay. Well, let's try adjusting those C ones then. Switch needs to be in central position. I think you're right, George. I think, see, at the start of the instructions, they said GND position, but I think you might be right about that. There we go. Bam. Okay. Yeah. See, on step 4 it says set the couple switch to GND. Whatever. Okay, so there's our 1 kilohertz signal. Now we're getting somewhere. Okay, right, so now we need to adjust C3 so sharp rectangle is obtained. Okay, so where is C3? Oh, it's visible through the top there. Those green dudes through there and there. Okay. So let's adjust those. I need a small one of them. Right, so which one is which? I need to stick my head around the camera. C3 is on the right, C5 is on the left. Okay. Oh yeah, so if we go all the way hard over to the left, does this turn infinitely? Yes, it does. Well, it turns a lot anyway. Yeah, okay, so we need to adjust that so we get a nice clean signal. If I change the trigger a sec. Yeah, that's just trigger mode. Okay, that's fine. I think that's as stable as it's going to get. That's sharp. I mean, it's jumpy as all hell, but it's doing stuff. Okay, right. C5 calibrations and push adjust to see test signal to 3.3 volts. Right. Push adjust. What am I changing there with adjust? Oh, the amplitude to 3.3 volts. Okay. Change sensitivity to 1 volt. There's our 1 volt. And I see no visible change as I turn that around. I'm going round and round and I see no visible change. However, it looks fairly square to me, so I think that's fine. Okay, the adjustment is done. Step 6, put all parts together. All right. So let's assemble it and see how it looks with that in mind. Cool. All right, so power off. Right, so let's do a quick demonstration on what we can do with this thing. Firstly, I'm going to show you a basis of comparison using my multimeter. So I've got here a MacBook Pro logic board that is switched on and just sitting idle with no boot device. Now, this section here, this is the buck converter for PP-Bus G3 Hot, which is the main 12-volt rail powering most of the stuff on this board. So these two transistors here switch on and off rapidly to cut the 18 volts from the charger down to about 12.5 volts or so. Now, if I measure that with my multimeter, we'll see there's our 18 volts from the charger. And then if we measure on the output of the transistor, you can see we have about 12.6, which is what the rail should be at. And if I measure anywhere else in this circuit, we'll see about 12.6-ish on all of the output. So on the two transistors and the inductor. Okay, so now with the oscilloscope, firstly, ignore the sort of flickering background. That's just the camera picking that up. The grid on the background is actually pretty static when you look at it with the naked eye. Although, of course, the line is going to jitter a little bit. That's perfectly normal. So as you can see, the screen doesn't have a fantastic viewing angle, but it's a hobby kit. What do you want? So yeah. Anyway, so let me just show you a couple of features of this. So firstly, in order to understand the layout, I had a lot of trouble with this when I was figuring it out while assembling it. But it's actually very simple once you understand it. Notice that we've got various colors on the screen. So we've got, for the seconds per division, we've got green seconds per division. Then we also have a green bar at the top here, which is our horizontal alignment. Then on the left here, we've got the voltage per division. Now this is in yellow for voltage related stuff. And in addition to that, we have a yellow notch at the side there for the vertical alignment. And then finally, over on the right-hand side, we have purple, as I'm going to refer to that as, for the triggering system. So for the trigger, we've got purple trigger settings and a purple trigger point in the top right. Initially, when I was calibrating this, by default, the trigger was down on the at 0, which is why it was very jittery while I was calibrating it, because it was constantly triggering all the time. So now I can demonstrate this. You can see we have a turquoise selector box around the seconds per division. If I tap that again, now the horizontal alignment bar has turned to turquoise to indicate where the selection is. So now the adjustment wheel is moving that left and right. And then likewise, if we tap that again, it moves back down to here. If I press volts per division, we've now moved the selector to there, so we're changing volts per division. And if I tap that again, the selector moves to here, so I'm now adjusting the vertical alignment, like so. And then likewise, if we hit the trigger, we're going to move the selector to there, and then if I tap that again, it moves up to the trigger point up here, so now we can adjust the trigger point. And if we put that down to 0, then it's going to start messing about with the trigger. So I'm going to leave that up there just to keep the trigger out of the way. So the other thing that we can do is if I hold down the OK button, it will give us on-screen measurements. So as you can see, now we have the on-screen measurements for what we're reading. Now, because this kind of gets in the way, what I've been tending to do is to move my vertical alignment right down here. So we're going to put that down to, say, let's put it about there or so. So now my waveform is going to appear here underneath the writing. What would have been handy is if all this stuff appeared at the bottom of the screen instead of the top, since most of the time you're generally going to be reading positive waveforms. But, you know, whatever, hobby kit, blah, blah, blah. So now we've gone over the basic settings for this thing. Let's show you a couple of demonstrations on stuff that it can do. So firstly, let's just show you the calibration waveform again. So if I touch the test output, so as you can see, we're now getting a waveform out of it. So let's just change my volts per division. Let's just set that to there. Let's bring my trigger up because it's triggering. Let's put that all the way up the top. And now let's change the seconds per division to a longer time frame. So if we set that to 0.5 milliseconds, as you can see, we're now seeing that square wave. And let's just increase our volts just to crush that down a bit. So there is our 1 kilohertz 50% duty cycle waveform coming out of the test signal. Now, what we can also do is start measuring voltages. So if we measure, let's set the volts per division to 5 volts because we're going to go on to some high voltage stuff. And let's touch that 18 volt input. So as you can see now, the wave has just simply jumped straight up the screen and we have a flat 18 volts, or in this case it's reading a bit high. We've got the flat 18-ish volts coming into the buck converter. So once again, we can increase those volts per division. So if we set that to 10 volts per division, we're now seeing 10 and just under 20. So now if we read the output from that, now as you can see, we're seeing something a little bit different here. Now firstly, notice that the average is 12.57, so about 12.5-ish, which is again what the multimeter was showing us, which is beeping at me to turn it off. Now here comes the interesting bit. Now if we slow this down, whoops, to 10 microseconds per division, we're actually seeing a wave. We can see the duty cycle of the wave as the transistor switches on and off rapidly. And we're seeing that the maximum is 18 volts from our input. And then as it switches off, that drops off to about 4.5 volts. But before it can completely drop off, it switches back on again. And it's averaging out at about 12.57. But you don't really want to power a circuit on a wave like that. We need to smooth it out. So the next thing it does is we go over to the input of our inductor, where we can see the same waveform from there. And now if we move to the other side of the inductor, the coil, we'll see that the coil has completely ironed that out to a flat 12.5 volts. So as you can see, using the oscilloscope, we get a much more detailed picture of what's going on in this buck converter. And we can do the same thing in another place on the circuit. Let's go up to CPU vCore that's over in this area. Let's just have a poke around here. That's 12 volts. That's an output. So here's the 12.5 volt input to CPU vCore. So that's coming off of this buck converter, and obviously it's a nice flat input as it should be. Now if we probe the outputs of that transistor, there's another waveform there. Let's just bring down our volts per division because we're working at a much lower voltage here. So let's bring that down to 2 volts per division. I'm just going to V-align that down a bit just so we can see it better. And as you can see, this is bouncing from between about 5.2 and 0, averaging at about 1.2 volts, which is what our CPU wants to run at. And if we move up to the inductor, we'll see the same waveform there. And on the other side of the inductor, we can, whoops, and I just shorted that to ground. Good job, Graham. Let me just turn it back on again. I accidentally touched the coil to the ground of the thing. Let me start this thing back up. And as you can see, on the other side of the coil, we have a nice 1 volts, which is what the CPU wants to run on. So wavy line on the input, flat line on the output. And obviously the multimeter will only show you the average of all of these at best. It will average it out. It will average it on the minimum and maximum. So, and that will also be biased depending on the duty cycle. But the oscilloscope can actually show us the real signal there. Now you can also do loads of other cool stuff with oscilloscopes, but I'm still really new to these. So that's just a quick example on what we have achieved with this device. So it allows us a nice little window into how these circuits are actually working in real time. So that was the JYETech oscilloscope kit. I hope you enjoyed it. Thank you very much for watching, everyone. I'll see you all in another video. Goodbye for now.